only a very small part of the incredible diversity of the universe. And today, we're going to take a plunge into its most mysterious depths. Our virtual journey will begin alongside the legendary Voyagers, which have been traveling through the expanses of space for decades now. After whizzing through the icy darkness of interstellar space, we will visit several of our nearest stars, including the amazing Alpha Centauri. And after that, we will dive into the uncharted depths of the Milky Way to find rogue planets hidden in the darkness. Leaving millions of light years of space behind, we will finally reach the majestic Andromeda Galaxy, which has been attracting astronomers' attention for hundreds of years. As we continue on this fantastic journey, we will eventually reach the largest empty areas in the universe, voids which insatiably absorb even relic radiation. They are the inextinguishable, eternal echo of the Big Bang. Let's get ready, and we begin. Vast empty space. On the 15th of April 2021, the automatic space probe New Horizons became the fifth spacecraft in the history of the humanity to go beyond the point of 50 astronomical units from the Sun. It was the Voyagers that had crossed this mark before, with the probes Pioneer 10 and Pioneer 11 the first ever to do so. None of these space wanderers are likely to ever return to the Earth. With some of them still active on their missions, others have gone quiet forever. Spacecraft New Horizons. Start of mission 19th of January 2006. Distance to Earth 52 astronomical units. Speed 14 kilometers per second or 3 astronomical units per year. Main goal Pluto and Charon. Mission status successfully completed. Condition operational. Just like most other interplanetary space probes, New Horizons performed a gravity assist maneuver near Jupiter before setting out to its target. Not only did it greatly boost the spacecraft's speed, but also allowed it to capture high-quality images of the largest planet in the solar system alongside its satellites. Besides, the probe's cameras captured the first video ever of an erupting volcano on the surface of Jupiter's satellite Io. After the gravity boost had been completed, the probe made for the main target, Pluto. The spacecraft reached the planetoid's environs in January 2015. The mission's main goal was to explore Pluto and Charon from different perspectives that involved taking photos of and mapping these remote space object surfaces. In addition, the probe estimated the magnetic field's values and the solar wind activity close to the objects, and collected information about their atmospheres and surface reflection properties. It goes without saying that the program also involved search for Pluto's as yet undetected satellites and more accurate measurements of Pluto's orbit's parameters. Having completed the main mission, the probe continued to be useful. It flew beyond Pluto's orbit and went on to explore objects in the Kuiper Belt. That is how images of Quaoar, R1 and Arrokoth were produced. Thanks to the probe's cameras, the distances to the stars Proxima Centauri and Wolf 359 were measured. Unfortunately, the radioisotope generator on board the spacecraft is expected to start running low from 2026, and eventually all the meters will switch off one after another. New Horizons will continue on its way beyond the boundaries of the solar system, and by the year 2038, the distance between the probe and the Sun will have grown to be 100 astronomical units. By that time, the energy generator on board the spacecraft will have stopped operating completely, and it will be impossible to get any connection with it. Following a hyperbolic orbit, New Horizons will exit our system, never to come back. The same thing happened with two other probes, Pioneer 10 and Pioneer 11. They hit an escape trajectory from the solar system a while ago. In fact, they were the first automatic space probes ever to be sent into interstellar space by humans. Spacecraft Pioneer 10. Start of mission 3rd of March 1972. Distance to Earth 127 astronomical units. Speed approximately 12 kilometers per second or 2.5 astronomical units per year. Main goal Jupiter. Mission status successfully completed. Condition not operational. The spacecraft reached Jupiter's system on the 4th of December 1973 after completing a 641-day journey through space. During the mission, images of the gas giant's surface and its largest satellites were beamed back to the Earth, and the planet's atmospheric composition and magnetic field were gauged. In addition, Jupiter was found to emit 2.5 times more thermal energy than it receives from the Sun. The data, unique at the time, became the basis for understanding the makeup of gas giants and their satellites. The trajectory of the second probe, Pioneer 11, through space passed Jupiter too, but its main target was the other gas giant of our system, Saturn. The probe's scientific instruments gauged the planet's magnetic field, and the cameras on board took quite a few snapshots not only of the gas giant itself and its system of rings, but also two of its satellites, Titan and Mimas. According to the estimates, the current distance between Pioneer 11 and the center of our system is around 106 astronomical units. On completing their main mission, both probes continued on their way, moving further and further away from the Sun. Unfortunately, both of them are out of range now, with the last signal from Pioneer 10 received back in 2003. The last signal from Pioneer 11 was received in 1995. Supposedly, both of them are now rapidly moving beyond the boundaries of the solar system. Incidentally, having no chance of ever catching up with either of the two probes we're going to talk about next, the Pioneers were launched at a much earlier date. Spacecraft Voyager 1. Start of mission 5th of September 1977. Distance to Earth 154 astronomical units. Speed around 17 kilometers per second or 3.6 astronomical units per year. Main goal Jupiter and Saturn. Mission status successfully completed. Condition not fully operational. The contribution of Voyager 1 to the solar system's exploration can hardly be overestimated. It is thanks to this probe that several new Jupiter satellites were discovered, alongside its ring system, which was big news. The Voyager's cameras captured volcano eruptions on Io, and provided hard evidence that Jupiter's Great Red Spot is an enormous storm. The probe beamed back hundreds of photos of the largest planet of our solar system and its satellites. After the spacecraft crossed Neptune's orbit, the meters on board sent back a great amount of valuable data about interstellar plasma. Voyager 1 left both the Kuiper Belt and the heliopause behind a long while ago, and is now rapidly crossing the area of the solar system's scattered disk, making for the inner boundary of the hypothetical Oort cloud. It is not only the remotest man-made object in space, but also the fastest of all the spacecraft on their way to exit our system. Being the first space probe to have traveled that far from the center of the solar system, Voyager 1 offered scientists a unique opportunity to study the heliopause. This is the area around our Sun where solar wind pressure and interstellar gas pressure balance. When the charged particles emitted by the star collide with rarefied plasma, elaborate structures form out of elementary particles and magnetic fields. Studying them is crucial for understanding processes taking place in the universe. Unfortunately, by around the year 2025, the power of the radioisotope thermoelectric generators on board the probe will have run out completely, and the connection will have been lost. In 300 years, Voyager 1 is estimated to reach the inner boundary of the hypothetical Oort cloud. It will take the spacecraft approximately 30,000 years to go clean through. And after that, it will fly beyond the boundaries of the solar system. 10,000 years later still, the probe will fly by the star Gliese 445 at a distance of 1.6 light-years, and then it will eventually get lost in the infinite depths of outer space. Speaking about Voyager 1, we can't but mention its twin, launched from the Earth on the 20th of August 1977. Voyager 2 had Saturn, Uranus and Neptune for its targets, but it also approached Jupiter for a gravity boost. It's the images taken by this probe that allowed scientists to assume that there were subsurface oceans on Ganymede and Europa. On reaching Saturn, Voyager 2 gauged the gas giant's temperature and magnetic field and discovered several new satellites. It goes without saying that lots of snapshots were taken of both Saturn's surface and its rings. Next in line on the probe's way were Uranus and Neptune. The flyby yielded a great number of unique snapshots, and in total 17 of the two planets' satellites were discovered. Also, it was found that both Uranus and Neptune have ring systems. Under Neptune's gravitational influence, the spacecraft changed its trajectory and left the ecliptic plane. This meant that Voyager 2 wouldn't be able to approach the other objects in the solar system, but it still had other exciting things to look forward to. Thus, the probe was to collect invaluable data about interstellar plasma and cosmic wind, as well as to measure distances to stars and explore the heliosphere. The probe is currently as far as 128 astronomical units away from the center of our system, with the distance growing by 15.37 kilometers every second. It's going to take it around 42,000 years to approach Ross 248, a dim red dwarf in the constellation Andromeda. The minimal distance between Voyager 2 and the star will be about 1.7 light-years, and around 300,000 years since its launch, chances are it will fly by Sirius at a distance of 4.3 light-years. Unfortunately, it is impossible to distinguish such a tiny object from the Earth that far away.
Άσε το λαμπερό σου χαμόγελο να γίνει η υπογραφή σου. Η Colgate Max White Ultra διαπερνά την επιφάνεια των δοντιών και λευκαίνει σε βάθος σε μόλις 3 ημέρες. Γιατί όπως και αν χαμογελάς, το χαμόγελο...
More than 6 months to reach Mars by the most optimal trajectory. If we think about the legendary Voyagers, after 45 years of traveling through space, they managed to leave only the inner part of the solar system. They're destined to spend several of the next millennia drifting through the scattered disk and the hypothetical Oort cloud. The fastest spacecraft at the moment is the Parker Solar Probe, whose speed in 2025 will reach a record-breaking 194 kilometers per second. However, this will happen only due to the Sun's gravity, which will never allow it to leave the environs of our star, and so the probe is doomed to soon burn up in its photosphere. Apparently, chemical jet engines, which are currently so widespread, have exhausted their development potential and are hardly suitable for interstellar travel. Of course, there are various alternative concepts, such as nuclear pulse propulsion or solar sails, but implementation of either of these is hampered by a number of serious issues. It is highly likely that sooner or later, most of these difficulties will be overcome. Another important task crucial for long-distance travel should be taken into account, namely the creation of a stable and powerful source of energy. All modern spacecraft are relatively small in size and are equipped with reliable but low-power power sources. For example, autonomous research probes are usually powered by isotope batteries, which inevitably degrade over time. If we revisit the legendary Voyagers, it turns out that almost all of their systems have long since been de-energized, and the spacecraft themselves have been moving by inertia for many years. The ISS and other orbiting space stations combine solar panels and radioisotope thermal generators, but most of their power is consumed by life support systems, and the ion drives serve only to adjust the orbit. In the case of an extended manned mission to a remote planet or star, however, a spacecraft would need much more power. Meanwhile, 99% of the way to another star inevitably passes through interstellar space, devoid of obvious energy sources. Even radiation of the brightest stars is noticeably weaker here and dissipates in the vast expanses of space. Therefore, to travel to other worlds, we need an autonomous, powerful, and preferably inexhaustible source of energy. To figure out a potential way of solving this problem, we have to take a closer look at the universe's structure. It is there that a number of amazing physical processes can be observed, which might prove to contain a key to stars' secrets. To do this, we have to take a slight detour. In 2017, a collaborative effort of scientists from Princeton and Hong Kong yielded an incredible device that at first glance violates the fundamental laws of physics. A microscopic mechanism consisting of two toothed silicon plates spaced 100 nanometers apart was able to generate a small amount of energy, literally, from nothing. It would seem that such a phenomenon should grossly violate the law of conservation of energy, one of the fundamental principles of the universe's makeup. However, in fact, it is not as simple as that. The amazing device is based on the Casimir-Polder effect, discovered back in the middle of last century. Putting it simply, it boils down to this. If two thin plates are placed in a vacuum a very small distance apart, they will begin to be mutually attracted. The phenomenon is closely related to the Heisenberg's uncertainty principle, from which follows the existence of the so-called zero-point vacuum fluctuations. They are pairs of virtual particles that constantly appear at any point of the universe, by and large out of nowhere. However, their lifetime is only 10 to the power of minus 24 seconds, after which the particles disappear back into nothingness and the global balance is restored. At the same time, if virtual particles with any parameters are generated in open space, only those that have strictly defined wavelengths can be generated between the plates. Consequently, more numerous external particles press on the plates harder than internal ones. Just to illustrate, one can imagine that the space between the plates has a negative pressure. It's as if a little more substance were pumped out of the vacuum. The resulting mechanical tension can be transformed into an electric current, which is exactly what the Princeton and Hong Kong researchers did. And although the current was quite weak, it's the principle itself that matters. Because this way, our world receives energy virtually from nothing. Even a low-power source of inexhaustible energy is of enormous practical value. For example, as an autonomous power supply for microprocessors and other high-precision equipment. For example, the Voyagers equipped with such a hypothetical battery could still transmit data from their instruments to Earth. This opens up promising vistas for exploring deep space. Many interesting physical phenomena follow from the Casimir effect, one of which is the so-called Scharnhorst effect. According to calculations, the speed of light in the space between the plates should exceed the standard value of 300,000 kilometers per second because there are no collisions of photons with virtual particles. Although modern technology does not yet allow this experiment to be carried out, its mathematical justification leads to far-reaching conclusions. For example, the widely known project of the hypothetical superluminal engine known as Alcubierre's bubble was proven to be potentially feasible by scientists from Baylor University, Gerald Cleaver and Richard Debussy. They combined the equations of quantum field theory and the general theory of relativity, producing a complex but clear rationale for a bold concept. It is worth mentioning that according to quantum field theory, space has not 3 dimensions but many more. But this becomes noticeable only at the level of the microcosm. Applying the equations of this theory to calculate the Casimir effect, the researchers came to the conclusion that it is possible to control its properties with the help of a powerful energy impact. If we condense the space behind the hypothetical starship and make it more rarefied in front, then there appears an area similar to the Alcubierre bubble, which is capable of moving at superluminal speeds. The laws of relativity are not violated here, because it is not the ship itself that is moving, but the space around it. On the other hand, From the very beginning, the main problem of creating such a bubble was considered to be the incredible amount of energy required. According to some calculations, an entire planet must be converted into radiation to form a sphere capable of accommodating a starship. If researchers manage to scale generators based on the Casimir effect to the required capacity, we will be able to obtain energy anywhere in the universe, literally from nothing. Of course, there are still many problems to address for a starship to be fully operational, because outer space is not the most friendly environment for humans. For example, it is permeated with deadly radiation, which not only destroys cells of living organisms, but also causes negative mutations in their offspring. Thick metal shields or magnetic fields with certain parameters may be used as protection against it, and both of these approaches have their advantages and disadvantages. Another potential threat could be accidental collisions with micrometeorites and cosmic dust. At high velocities, even a tiny grain of sand has incredible kinetic energy and can pierce through a metal plate. It goes without saying that on a long interstellar flight, repair options are extremely limited, and a hole in the hull may prove to be fatal. In addition, a long expedition without support from Earth requires creating a closed biosphere within the starship. Scientists from different countries are currently working on this. For example, various plants have been grown on board the ISS for quite a number of years, both for scientific purposes and for consumption. In addition to that, engineers are developing systems for recycling waste, including biological waste products. However, a fully fledged orbital ecosystem is still a long way off.